Greetings, everybody. This is Eric Andelin with SimActive. I am happy to have with me Carlos Prieto. Carlos, go ahead and introduce yourself.
Hello, everyone. My name is Carlos Prieto. I am with SurvTech Solutions. I am currently the Vice President of Program Management, and SurvTech Solutions is headquartered in Tampa, Florida. We started as a purely survey company back in 2004, and over the years have evolved to a full-blown geospatial company. We have a range of different services, everything geospatial. We collect and map just about every feature there's out there. We can do mapping from the air, on the ground, underwater, underground, several different combinations. We have airborne capabilities with LiDAR and imagery. We do a lot of large-scale collection supporting different federal outfits, USGS, the Corps of Engineers, NOAA, and so forth. We have several offices throughout the Southeast, 13 states that we have PLS coverage throughout the Southeast. We're a fairly young company, around 100 employees or so, but we're still a small company, and we're agile and nimble, to be able to deploy just about anywhere.
Yeah, and for the people listening and those that are watching the presentation, I've known SurvTech for quite a long time. I've known Ken and Carlos and David, great folks, always working with the latest, greatest technology. So I'm really happy to have you guys on board. You guys are SimActive users. That's one of the tools in your toolbox for processing. And what we're really here to talk about today is what you guys are doing with drones, what you guys are doing with imagery, drone-based LiDAR, and how these apply to the projects that you guys are working on. I know you guys work with full-size cameras as well.
We do. So we own an optic Galaxy T2000, and it has an incorporated phase one metric camera, the RS1000. So we can do concurrent collection of both elevation data and imagery.
Let's talk about the phase one for just a minute. Maybe some of our listeners don't know. We tend to have folks that work on the drone spectrum, and we have folks that work on the large format. But something that's really taken off in the last, I'd say 2-3 years, are the medium format cameras, and phase one really puts out a good product. And when you mate that with a LiDAR system, then you now have the ability to do point cloud colorization and so forth. And what are your thoughts on the phase one systems?
Well, it has worked very well for us. It's a metric camera, and it has calibration, so you can do mapping out of a stereo compilation. You can do ortho imagery, and again, the ability to collect concurrent image and LiDAR data. It's a huge benefit for a lot of our customers, especially in the utility corridors where imagery and elevation data is much more needed nowadays.
So what we're going to talk about is specific to utilities in this case, the challenges with setting up projects for utility mapping. We'll go over some of the processing tools, and we'll also look at maybe some of the batch editing and scripting tools that can help you get to your desired deliverables using correlated 3D or, in fact, anything else if that's what you're using. And again, our software is only a piece of the pie because, you need processing software for LiDAR, you need processing software for your survey data, all of that. Before we get down that road, I know you also have a handful of drones with you. Can you describe what you guys have, what what you're using them for?
Yeah, sure. And by the way, I personally have been using correlated 3D for the last 10 years or so. So I'm well acquainted. I have seen the evolution of the software, and I'm pleased with the with the latest updates.
Good.
But yeah, we have an array of UAVs, and they are equipped with either LiDAR or imagery. Our latest image UAV is the Wingcraft 1, the Generation 2, and it has a 42 megapixel Sony camera. It has a very good endurance. It's a very stable platform. It can stay up in the air for a considerable amount of time. You can cover a lot of ground in a single mission, and the resolution of the camera is such that even at 400 feet, which is the maximum allowed for UAV flying, you still get under a couple of centimeter pixels. Right. So very high resolution imagery capture, with that platform.
And I also saw you guys have a Harris system.
We do. So we have the heavy lift, the H6, which is a hybrid electric gas powered. That handles our lighter payloads. We have a Velodyne 32, and we also have a Regal Lux 1. It handles either one of them very well. It stays up in the air for about 90 minutes, so you get a lot of collection in a single mission. We like that. We also have a couple of the DJI 600s that we may be retiring soon. We just acquired the newest Harris, the HX8, as a matter of fact. So that's an fully electric drone, can handle the lighter payload with about 30 minutes endurance. That pretty much doubles the DJI endurance. So that one is working very well, with our UAV crews.
Yeah, that's fantastic. And I assume, when you guys are looking at these systems, and I agree, the Wingtra is just a fantastic. It's a workhorse. In the Harris systems, I don't think you can beat them for heavy lift. So let's dip in. I know your background is survey and photogrammetry, so is mine.
I come from a stereo compilation background.
There you go. The good old days of stereo photogrammetry. And so let's talk a little bit about what you guys are doing. So you guys are doing some utility corridor mapping. Is this typically for vegetation obstruction stuff? Is it for new projects?
It's a variety. Some of it is new projects. Some of it is just asset management, vegetation management.
There is a difference between what you're doing when you're setting up a project where you're doing land development, and it's 600 acres and it's kind of a square shape. You can target it a certain way. You can set your project up a certain way. But when you're dealing with corridors, and I'm not even talking just about utility corridors, but also roadways, there are requirements to setting up your project so that your processing software can properly create the AT, match the targets, and so forth. So can you talk a little bit about that?
Mission planning is critical, to the success of the project, especially in corridors, where there's different shapes and they meander here and there. We tend to kind of block things up. Yep. And just because it provides a much stronger solution when you're calibrating your data or when you do an aerial triangulation, for feature extraction or ortho imagery.
Yeah, and it's important with utilities, but it's more important on road projects if you're working with a drone. Obviously, you're not supposed to be flying over the road. So you want to run parallel on both sides. So you've got at least 2 flight lines. You need more than that. I think sometimes some errors that we see in the drone world is that they think that, just a couple of flight lines will do. What you need is that network of tie points. So you need multiple flight lines through your corridor. More so important in the drone world, but in the medium format and then in a large format, if you're not doing stereo photogrammetry, and you're relying on a tight AT solution for structure from motion, you need quite a few flight lines.
Yeah, and we find ourselves, controlling each block or each job in very much the same way, regardless of whether there's going to be compilation or there's going to be, other products. Because oftentimes you acquire a data set and the client keeps coming back and saying, hey, by the way, can we do this with this data set, or can we do that?
Yeah.
So, nowadays getting control is really not all that expensive. I mean, you're already on site. Yeah. Our crews, our UAV crews and our airborne crews are both equipped with GPS technology. They know how to set control and that sort of thing. So, we treat every project, with that kind of precision and accuracy in mind. I said earlier that we're a full blown geospatial company, but we're still surveyors at heart, and by that I mean we treat every job with the same care and the same pursuit for accuracy as we do any other job, and that includes setting a good density of control points that will ensure not only that you have success, but you can prove to the client that your product meets the accuracy desired.
Yeah, and to that point, proof is not just an accuracy report from your software. I mean, you have to be able to back it up. People may not understand that, or they may want to just hand the report to someone and say, well, this says it's good. And that may not be enough to make your client happy. So you have to be aware of that.
Well, mapping standards make it clear that you have to have independent checks. So, we typically will collect an independent group of points, checkpoints that you can verify the accuracy of the data, you can report against it. And then, we've had success doing that.
Yeah, I always tell folks, at a minimum, you want control for this reason. If your IMU fails, if you're in the drone world, if you're not capturing that data and you just assume that RTK or PPK is the answer, how are you going to know if you don't have checkpoints? You just don't. So you have to be aware of that.
Absolutely. Mapping standards will dictate for whoever you're working for, USGS or the Corps of Engineers or the DOT. Their mapping standards will dictate, how the data needs to be assessed for accuracy, and that includes having independent, control points.
Yep, very good. So, again,
one more thing before I forget. The ASPRS mapping standards dictate that your control has to be 3 times more accurate than the desired accuracy of your data set. So, that's a very important point, because, those last centimeters of accuracy will cost you a lot of money, if your client is interested in having super accurate data. You're within 10 centimeters, 5 centimeters, even a couple of centimeters, RTK technology would be fine for control points. But if you want to go more accurate than that, then you start talking about leveling techniques, and that can increase your budget exponentially.
So let's talk a little bit about. So we have 2 sensors that we're primarily working with these days: RGB sensors or image-based sensors, and we have LiDAR sensors. And we are now to the point where we are merging those 2 technologies so that we're reaping the best of both worlds from each of them. And honestly, with the advent of medium format cameras, with the advent of drones, in the old days when you had a large format system, to put a LiDAR unit and a camera in that aircraft, and then to deal with the flight lines based on maybe the focal length of the camera or the LiDAR unit, created all kinds of challenges, and it's fairly costly. When we go to medium format, now we can start adjusting things in the flying height so that the 2 are closer in unison. And then we can even drop down, like you said, again, to say drones, where we can fly two at the same time and collect the information. So it's made things easier for us to work with both data sets. And in correlated 3D, we can bring in the point cloud data. We can put that with the imagery. We can use the surface from the point cloud data, or we can create the surface from the imagery. We can do a lot of things to merge these data sets together. And more recently, the ability to do the point cloud colorization. So can you talk a little bit about the benefits of each and what the value is when we combine them to create products?
Elevation data is so valuable nowadays, and it could be used, for a variety of different projects. Image data is also valuable. The visual impact, the ability to record features on the ground.
Yes.
At the time they were collected. I mean, it's just a permanent record. Combine the two together, and then the value of the data set just increases exponentially. Now you can use your LiDAR elevation data to rectify your imagery. You can use your imagery to aid in the classification, in the proper classification of your LiDAR data. You can use the RGB values from the imagery to colorize your point cloud, and these are all things that can be achieved, through a variety of different softwares, but it can also be achieved in correlated 3D. I like that ability. I like having that quick access in a single platform. Oftentimes, we bring in the elevation data, produce a quick DEM, or filter the data in correlated 3D just to produce a suitable elevation model, for orthorectification. Merging the two data sets together, yes, you're absolutely right, increases the value of the data exponentially.
To that point, we bring in processed point clouds. We don't correct point clouds. We don't do anything like that. There is software that is best used for that. And that software may do some of the same things that we do. So there's a little bit of overlap, which is fine. But when you're busy, when your company is running through different LiDAR data sets, be it terrestrial, be it mobile, be it airborne, that software may be better used for that purpose, whereas we're an image processing software. So on our end, we may be able to relieve some of your congestion on your LiDAR processing software by doing some of these steps in here, and vice versa. We don't do planimetric mapping. Planimetrics are better done in your CAD software or whatever else you're doing. So, talk a little bit about what kind of software you guys are using to process LiDAR data.
We use, the TerraSolid suite of software. That software is very, very powerful, to have full control of your LiDAR data. That's where we do it. Once it's calibrated, then that point cloud can be shared in correlated 3D, be able to produce, surfaces for ortho rectification. So yes, we still keep full control over our LiDAR data in the TerraSolid environment. Once we're happy with, we achieve a strong calibrated point cloud, then we can share it with correlated 3D for further processing, for the analysis, or for ortho rectification.
Yeah, that's a great way to put it, is to share it with this software package to go ahead and produce additional deliverables. So now we've added a few things. We just had an update a few weeks ago, and the one thing that excites me the most, I'm just a geek, is the email notification. I love the fact that now when our users are processing data, they can literally just put their email address in there and it'll shoot you an email, because you're processing stuff 24/7 overnight. You might kick off something at 5 p.m. And in large projects, you may get an email at 10 p.m. saying that the DSM is done or the orthorectification is done. Originally, we could import one LAS or LAZ file, which required the client to merge all of their LiDAR data into one cloud, which can be really big depending on your project. And then bring that into Correlator 3D, do our work with it, do the colorization. We have now added the ability to load multiple LAS files, so you don't have to merge it together on your end. You can do the colorization the same way through a batch routine that just basically loops through the software and then colorizes each of those individual point clouds. And I don't, Carlos, I don't know if you have dug your hands into that. It may be more of your production team.
Well, like I said, I've been using Correlator 3D for the last 10 years or so I'm happy to see the improvements over time. The email function, thumbs up for that, because a lot of the projects are smaller projects, a few hundred frames here and there, but we run projects with thousands of frames. Just last month we ran one with 4,500 frames. So it takes a lot of time and the ability to be notified when some of these processes and they're ready for the next step. Yep. Regardless of where you are, with the email feature. Now, the ability to bring multiple LiDAR, files into Correlator 3D, I'll give you 2 thumbs up for that, because you're absolutely right. And the majority of the larger LiDAR projects are, outputted into tiles.
Yeah.
So you were having to output tiles from TerraSolid, from TerraScan or any other software, and then before this month, you had to kind of find a way to put it together, upload it. Now, you just go select all your files there. That's a great advantage.
Yep. And and I'll show in the demo that to do that, to import them in is not a problem. To create the surface is not a problem. Creating the intensity image, which you can then use for for some of your control. All those things are straightforward and very easy to do. The colorization of individual LAS files takes a little bit of work. It's a little bit of scripting, which we're more than happy to share. But more importantly, it goes back to what I tell people all the time when they are new to this. Create a directory structure that you're going to work with. Stay with that structure. Make it homogeneous to all your projects. And in the case of some of these scripting routines, think about those and make it simple for you to write these scripts. So your tile names, your file names, all of those things, consider them ahead of time, because they will create roadblocks in some cases. So people need to be aware of that when they do some of these scripting routines. They can make it
by the way,
easier.
this scripting has been, with Correlator 3D since the beginning, I believe.
Yep.
And I'm particularly fond of that. I'm a little bit old school and writing scripts, simple scripts, DOS scripts, and I say DOS, and a lot of people don't even know what I'm talking about, but I know that capability has been in there, and we use it pretty often, especially when we have projects that are very similar, or when we're running processes that are redundant. You may have one flavor of a project that has maybe 10 different sites. You can script that together and do a lot of the processing unattended. Great feature.
Absolutely, and even for those people that are doing, say, queries or things like that, where every month they're going out and doing the same thing, write a script, and then point it to the folder where the new imagery is, and let it do its job. Make life easier on yourself. Okay, before we get started, let's go ahead and make sure that we have our email notifications set up. So you can see here in the general settings, here we've got email notifications, and then here's a toggle button for on process completion. You have a couple options here, which are your script status update. In other words, do you want it per process? In other words, when the AT is done, then again when the DSM is completed, then again when the DTM is completed, and so on. Or do you want it strictly per script. So if you have a script and it's got a list of things to do, you just want it to tell you when it's completely finished. You have either choice. Right now we'll leave it on per process. And then here you can see you do your email configuration, put in your password. Now these are the recipients. These are who these notifications are going to go to. So you can see I have my personal email address. Also down here I have my phone number, and it's attached to Google Fi, which I can set up to receive emails as text messages. And if you want to know how to do that, you can Google it on the internet, and you should be able to find, based on your carrier, how you can send emails via text. But anyhow, once you're done with that, you can send a test email to yourself. You should be able to check it any minute, and the test will be there. From then on, once you start processing data, you will receive notifications. So we'll leave that alone. And we'll go ahead and start looking at how we can now import LiDAR data. So previously, the way we would import LiDAR data is that the user would merge all their LiDAR data files into one, which we could then just grab and import. Say, for example, this one. Of course, we have to extract the DTM. You can see it's one file and it's 784 megabyte. We'll go ahead and run that. And there we have our one file imported as a DSM. So now we've added the ability to import multiple LAS files, and I'll go ahead and just let this go. And just like Carlos had mentioned earlier, the benefit of this is A, you don't have to put them all together, but B, they're smaller files to work with. So let's just go ahead. I know they're all in this folder, so I'll grab them. Here are 16 files. These represent the same area. It's just that these are the original ones that were extracted from the LiDAR software. So we'll go ahead and we'll run this again, extract the DTM, and let her rip. So either way, if you bring in an individual file or you bring in multiple files, again, we're not a point cloud-based software, we're a raster-based software, so it's going to convert it into a DSM. And then from there, we can go about our normal workflow. So let's switch over to a project that is complete, and we'll take a look at So here we have the results of the process data set. And as I understand from Carlos, this is just a portion of this corridor that they worked on. We can turn off the images or the photo centers and the flight lines so that we can see a little bit more in detail. Here we have some control points in here. We also have our finished mosaic right here. The DSM again came from the LiDAR, so let me turn off the mosaic and the reference orthos. So we started with the DSM, it's loading that right now. We ran our DTM generation algorithm to strip out the buildings and so forth to give us our DSM. From that, we went ahead and did the orthos and the mosaics. So now we have a mosaic. We do have the reference orthos that came in with the DSM. So as you can see, the density of these orthos, again, is pretty darn good, when you're talking about data from drones. So, if you wanted to add a checkpoint, for example, we could go in here, add checkpoint, and say I just selected this corner right here. And it's going to pull up that corner in the image, and we can go ahead and measure these points. So we've got the ability again to add points from the intensity image of the LiDAR. So the software is going to pull the XY location from the intensity image, and it's going to pull the Z value from the DSM or the DTM that was produced underneath it on import. So if we went through and measured all of these, the next step would be to just change this into a checkpoint and save it. We could go ahead and reprocess the AT and see the results there, but I just wanted to show that feature. So let's get back out of the AT. The last thing again would be to do the point cloud colorization. So if it were a single point cloud, we would simply reload the point cloud. So add to project, point cloud. From there, once we had that, as long as we have the mosaic turned on, we would go up to the menu and point cloud colorization, and then it would go ahead and do the colorization for the point cloud. However, now that we have multiple LAS files, we wouldn't necessarily want to do that. That would be time consuming, especially considering in this project there are 16 LAS files. We could do each one individually and it would get us the same result. Rather than that, why don't we look at doing some scripting and batch process this so that the software will go ahead and run all of them unto completion. So let's take a look at that. First, we need a script file. So this is an example of a point cloud colorization script file. And we just need a few pieces of information here, like where is the input point cloud? And it's in this folder right here. And it's down here, but in order to run batches, we need to make sure that it's in a folder structure that the software can work with. So what I've done is I've created folders 01, 02, 03. Inside of 01, I have put the first LAZ file. And this is also where the script file resides. So it's pointing to this folder and file. It's also telling it where the mosaic is. And it's also telling it what it wants the output file to be. To do this, we have to do it for each file and each folder. So script 2 is the same thing. All I've done is change the folder and the file names. Script 3, same thing. So you want to make sure that when you create this file structure, you want to make it simple so that it's easy to edit your SPT file. Okay, so we have that done. And in order to get it to run, we need to also have a couple of batch files in that folder so that it can call Correlator 3D, and then Correlator 3D can in return cycle through those folders and run the script. So the call to Correlator 3D would be this right here, which just says in this folder, open up Correlator 3D and run the next batch file. The next batch file is the run batch file, and it's calling Correlator 3D, and it's saying in this folder is where we want to process the SPT file, and go ahead and cycle through all the folders till you're complete. So once everything's in the right location as it is, we can just hit the go bat file and it will start processing. Please note that if you have Correlator 3D open, then it will not process. It'll come to a halt. So you want to make sure that Correlator 3D is closed. This is running again from command line, and it is going right now, and it's producing these 3 colorized LAS files from the original. Understandably, if I wanted to do this for all 16 files, I would make sure that I have a folder for each one. And again, the SPT file has been written and included in that folder to process the data. So we're done with 1 and 2, and 3 is finishing up right now. And the nice thing is, again, this is command line. We don't even have to open up Correlator 3D to do this. By the way, it is also sending a text message telling me that these are complete, which is kind of nice. I don't even look at my email anymore. Who does? I just send it automatically to text. So this is a nice way to validate that it's done. So we're done. Now, if we take a look in the folder, we have the original, and we also have a new colorized point cloud file as well. And we can actually look at that. Hang on here and see if I've got Poetry loaded here. Yep. Of course, it's blocking my view. We'll go ahead and grab the LAZ, drop it in. I want to convert it, start conversion. And there we have our colorized file. Now, again, obviously, you don't take out information typically in these files because you'll just classify them out later on. But as you can see, colorization looks pretty good. And of course, we can do this to review every point cloud as well. That's the basics of it. That's the beauty of scripting and batching in correlated 3D. I strongly advise, if you're working quite a bit, like Carlos mentioned, if you're working in the same thing or the same areas and you're producing the same deliverable, you can efficiently or more efficiently use correlated 3D to create those outputs through scripting and batching. And there's a lot of information in our help menu about that. There is a sample scripting data set or scripting dialog that will walk you through all the steps. And of course, in our knowledge base, we also have additional information on that as well. I want to thank everybody for their time and Carlos for joining us. Do you have any additional comments?
We apply solutions to mapping challenges, like nobody else. We're a full-grown geospatial company now. Give us a call if you have any more questions. Reach out to me if you have any questions. We're happy to help.
Okay. Thank you again, Carlos. Appreciate your joining us, and everybody for attending this webinar. Thank you very much.